Okay, let's go into example. We've been able to understand the concept of Taylor series, the definition, this the formula, and breaking down the formula, we have this expression, this expression in terms of what series. Okay, now we've been able to what break down the formula. Now let's use it to solve an example. Look at this beautiful example. The example says that write out the first four terms. You know, Taylor series is to infinity. It's very long, to infinity. But the question says write out the first four. 1, 2, 3, 4, and you stop. Write out the first four terms of the Taylor series about a is equal to 2. That is, anywhere you see a is equal to what? 2. For the function, you'll be giving your function f of x. What is my f of x? Lane x. So I can say that f of x, which I told you guys that is the same thing as f of 0 of x. That is, you've not differentiated at all. Is the same thing as lane x. But you know, in my formula, I need f of a. So I can say that f of 0 of a. What is f of 0 of a? If f of 0 of x is equal to lane x, then f of 0 of a means that anywhere I see x here, I will replace it with what? A. Then I can say it's equal to lane a. Why? Because it is function of x, but a is acting as the domain. We call it a is acting as what? As the domain. But what is the value for a? The value for a, the question says at about a is equal to 2. Then I can say what is equal to what? Lane 2. Okay, but in the formula, that's for f of a. We have f1 of a. So to get f1 of a, I'll have to differentiate this by saying f prime of x, meaning you want to differentiate lane x1 once. And if you differentiate lane x once, the answer is 1 over x. Since I've gotten this to be 1 over x, then I can say that f1 of a, meaning since f1 of x is this, anywhere I see x, I put what? A. That's the same thing as 1 over a. But what is a? 2, which is the same thing as 1 over 2. If I differentiate again, I have f2 of x. If you differentiate this, what is this? What is here is the same thing as, I can say that what is here is the same thing as x raised to power minus 1. And according to the law of according to the standard definition of differentiation, if I'm to differentiate this, is the same thing as minus 1 x raised to power minus 2. Okay, I've differentiated. Or I can say it's the same thing as, from law of indices, minus 1 over x squared. How did I get that? Law of indices. This minus will turn to 1 over, change that from law of indices. Okay, so I've gotten the second derivative of x. Since I've gotten the second derivative of x, then I can say that f2 of a, anywhere I see x here, I represent it with what? A. But what is a? 2. That's the same thing as minus 1 over 2 squared. And 2 squared is what? 4. That's the same thing as minus 1 over 4. The question says, write out the first 4 terms. This will be the first term, f of 0. This will be the second term. This will be the third term. Then I'll have to differentiate again to have the what? Fourth term. Then I'll stop there. So I can say that f3 of x is the same thing as, I want to differentiate this. If I differentiate what is there, minus 2 times minus 1, 2. That's 2. Write your function back, subtract 1 from the power, minus 3. Or I say it's the same thing as, 2 over x raised to power 3. I've differentiated. That's from differentiation. So the knowledge of differentiation is very, very, very important under Taylor series. Okay, now I can now say f3 of a is equal to 2 over a raised to power 3. But what is a? We are giving a to be 2. That's the same thing as 2 over 2 raised to power 3. 2 raised to power 3 is what? 8, which is the same thing as 2 over 8 or 1 over 4. Okay, so the question says write out the first 4 terms. I can say first term, second term, third one, fourth one, then I'll stop here. Then I can write out my series by saying the answer is the same thing as the Taylor series of ln x at about a is equal to 2 is equal to, now let's substitute everything here into this my answer. f0 of a. What is f0 of a? ln 2. That's ln 2 x minus a raised to power 0. Anything raised to power 0 is what? 1. The 0 factorial is what? 1. So everything here comes to what? 1. So 1 times this, which is ln 2, is still the same thing as ln 2. So the first term is what? ln 2. Plus f prime of a. F prime of a, we have that to be what? 1 over 2. That's 1 over 2 times x minus a. That's x minus a. What is a? 2. That's 2 raised to power 1 over 1 factorial. 1 factorial is still what? 1. Plus the next one is f2 of a. f2 of a is what? Minus 1 over 4. So the minus will affect this plus, because minus times plus is what? Minus. So this will be minus 1 over 4 into x minus a squared. That's x minus 2 squared over 2 factorial. What is 2 factorial? 2 times 1. That's 2. Plus, what is the next one? f3 of a. According to what is here, f3 of a is what? 1 over 4. That's plus 1 over 4 into bracket x minus a. What is a? 2 raised to power 3 over 3 factorial. What is 3 factorial? 3 times 2 times 1. 3 times 2, 6. 6 times 1, 6. That's 6. Plus dot 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 till infinity. But the question says write out the first 4. So we are going to stop at the first 4, which is 1, 2, 3, 4. That's the answer. But can we break that? Can we simplify? Yes. Then I can go into conclusion by saying it's the same thing as ln 2 plus x minus 2 over 2. 1 times this, I have this. 2 times 1, I have this. Minus x minus 2 square over 4 times 2, 8. Plus x minus 2 raised to power 3 over 4 times 6, 24. 24. Final answer. So the answer to ln x, the answer to Taylor series about a equals to 2 for the function f of x equals to ln x is the same thing as this. So that's Taylor series. Before you can solve the question on it, what you just have to do is you break down your f of x, fa, then you substitute everything into the formula. That's all. Thank you. Okay, another question of Taylor series. This question is from your past question. The question says that write out the first 4 terms of Taylor series. First 4 terms. You know the expression, you know the formula, you've been able to understand the concept behind the formula. So this should be very easy. About a, you must be given a. About a is equal to what? 1 for the function f of x. What is my function? The function is equal to x squared plus 2x plus 1. Okay, we all know that we have to what? Differentiate first. So I can say let's differentiate. If f of x is equal to x squared plus 2x plus 1, I'll look for f of a. Then I can say that f of a is equal to, anywhere I see x, I'll put what? A. But what is my a? My a is 1. So that would be 1 squared plus 2 times 1 plus 1, which is the same thing as 4. That's the first one. I've not differentiated. Now let's differentiate. f1 of x is equal to, meaning I want to differentiate this black f of x. If I differentiate that, I have 2x plus 2. If you differentiate x squared, you have 2x. If you differentiate 2x, you have 2. If you differentiate 1, you have what? 0. I've differentiated. Now I'll look for what? F of a. Then I can say that f prime of a is equal to, meaning anywhere you see x under f prime of x, you put what? A. And what is a? 1. Meaning anywhere I see x here, I'll put 1. So if I put 1 here, That would be 2 times 1, 2 plus 2, 4. That's what? 2 times 1 plus 2, which is the same thing as 4. I will differentiate again. I have f2 of x. If I differentiate 2x, I have 2. If I differentiate 2, I have what is 0. So what will be f2 of a? Meaning anywhere you see x, you put what? A. But since there's no x here at all, then the answer is the same thing as what is here, which is what? 2. If I differentiate again, f3 of x, that one is what is 0. Why? Because if you differentiate the constant, you have what is 0. Therefore, f3 of a will also be what is 0. So we stop there. Why? Because since our differentiation stop at 0, anything you keep on differentiating was 0, 0, 0, 0. And the question says write out the first 4 terms. This is the first one, the second one, the third one. But the third one is 0. Then it means others two is what is 0. Now, what is our formula? We all know the formula. By definition, Taylor series says that it's the same thing as f of a of x minus a raised to power 0 over 0 factorial. And we all know that anything raised to power 0 is what? 1. 0 factorial is what? 1. So this one is out of it. So we are left with ordinary f of a. So I can say that by definition, Taylor series is the same thing as. So I can say that since the 0 factorial and 0 cancel out, then I can say that Taylor series is f of a, is not differentiated at all, plus f prime of a into x minus a raised to power 1. Anything raised to power 1 is still that thing, over 1 factorial. 1 factorial is still 1. So I can see what is there is just like this. Plus f2 of a into x minus a squared over 2 factorial plus f3 of a into x minus a raised to power 3 over 3 factorial. The question says the first 4 terms, 1, 2, 3, 4. I'll stop there. So I can say my answer to this question is equal to f of a. What is my f of a? My f of a is what? 4. That's 4 plus f prime of a. What is f prime of a? F prime of a is what? 4. That's 4 into bracket x minus a. But what is the value for a? 1. That's 1 plus f2 of a. f2 of a is what? 2. That's 2 into bracket x minus a all squared. What is a? 1. That's 1 all squared over 2 factorial. But what is 2 factorial? 2 factorial is 2 times 1, 2. So I can clean this to say it is what? 2. But don't forget, 2 here 1, 2 here 1. Cancel out. Plus f cube of a. F cube of a is what? 0. Since this one is 0, the 0 multiplied by everything here will still give us 0. So this last one is what? Is 0. So I can say the final answer is 4 plus 4 into x minus 1 plus x minus 1 squared plus 0. Or I let go of this one by saying this is the final answer. So that's what we call Taylor series. And the question is from your past question. Thank you very much.